And besides,
5,000 ants.
superhero names, B-Man, no. Spider-Man, yes.
Ant-Man. A lot of ants. An awful lot of ants.
Ant-Man and the Wasp, yeah. Now we're getting into like reaching territory here. All right, so system of inequalities that represents the shaded region on the following graph. Now, if you did the IXL work, this kind of problem isn't really foreign to you. So I want to write the equation of each one, which means that I need two pieces of information. I need a slope and a y-intercept. So what I'm going to do is I'm just going to look at the graphs and identify a y-intercept and then a noticeable slope. All right, so for this line, I have a y-intercept of 3, so my b value is 3. And my slope, my m value, rise over run, 2/3. All right, so I'll hang on to that for a sec. All right, for the other one, looks like I have a b value of -1 and a slope. It's a little less obvious, but you know, you just gotta look for the solid points or the solid intersections. All right, it isn't until you get to this location where it crosses cleanly. So 1, 2, 3, 4 up, 2 to the left. So 4 over -2, rise over run, which is just -2. All right. So now when I want to write the inequalities, it's actually super easy, barely an inconvenience. So we're looking at y. Now, normally it would be y equals mx plus b, so I'll leave the equality or inequality out of it for a second. 2/3 x plus 3. Am I shading above or below this line? Below. Is it a solid line or a dashed line?
Solid.
Solid, so it gets a less than or equal to symbol. All right. For the other one, we're looking at, we got a y, we got a -2, x minus 1. All right. Am I shading above this line or below it? Above it. All right. It's a dashed line, so is that going to be, so it's either greater than or equal? Which one is it? Greater than. So I have my system of inequalities. That's all that question was asking you to do. Okay. Not too bad. All right. System of inequality word problems. It boils down to pretty much things that you were doing in class, except you have to come up with the equations first. All right. It's not going to be difficult once you have the equations. All right. The structure of the equations, inequalities, are going to be the same conceptually as they were in the previous unit, where we talk about unit price times the number of units giving us cost, things involving time and stuff like that. Those could come into play, but structurally it's going to be the same idea. So Paul earned $6 per hour at the bagel shop and $12 per hour mowing lawns. All right, so we're talking about hours being the variable. All right, so let x equal the number of hours at the bagel shop. When people mess up the word problems when it comes to equations or inequalities, they're typically messing it up right in the let statement part of it, right? Because they're not really defining their variables very well, and because of that, their inequalities or equations don't really make much sense. So if you don't define your variables very well, you're not really ever sure what it is you're looking for. So take a couple extra seconds and be a little bit more specific with your let x, let y equals, all right? So in this case, we have y equals number of hours mowing lawns. All right, so $6 per hour at the bagel shop and $12 per hour mowing lawns. He needs to earn at least $120 per week. All right, at least. What inequality symbol would be for at least? Greater than or equal to. So greater than or equal to 120. But he must work less than 30 hours per week. Well, X and Y represent the number of hours. put them together, that's the amount of hours that he's working. So x plus y has to be less than 30. Right? I mean, this seems like a problem that's only designated for, use in a math class, but really you could think about it in a real life context. You want to work, but you don't want to work too much. So you want to make as much money as you can while working as little as you can. Isn't that the whole point of this? I mean, you're trying to get good grades on math tests for a reason, I would think. Yeah, maybe you don't even think past beyond, like the getting into college. I just want to get into a good college. But why do you want to get into a good college? So you get a good job. What's the point of getting a good job? So you get rich, but what is rich? Making the most amount of money that you can while doing as little as possible, all right? So that's what this question is really talking about. Now, $6 and $12 an hour, that's not going to get it done, but at least it's the makings of the thinking behind, strategies that can kind of propel you for the rest of your life, all right? So then we want to create a graph out of this. Do we want to use the techniques like y equals mx plus b? Personally, I don't, because we're living in the first quadrant, all right? Which means that an x and y intercept is going to get the job done for me, all right? So that's what I'm going to do. I'm going to create. I like to do it in a little bit of a different way sometimes. A table approach can kind of be the most reasonable way. So let me just show you what I mean by that. So x-intercept, y-intercept, and then my first equation, so I'll say equation 1 and equation 2. All right, so here's my first equation. Here's my second equation. And again, the whole point behind me showing this technique to you is not to confuse you. It's to give you a quick and easy strategy for you to come up with the necessary information to create your graph. All right, because y equals mx plus b, the slope, sometimes it's really useful information. If the scale is small enough, it's perfectly fine. But sometimes, I mean, if you have to scale your graph by like 5s, 10s, 2.5s, counting off a slope of -7/3 may not be the easiest thing in the world to do. Right? So the x and y intercept approach tends to be the better way to go. So what we do for the x-intercept in my first equation, again, is we just cover the irrelevant variable. Right? So I'm covering my y variable. So I'm solving 6x equals 120. What do I get? 6x equals 120? 20. 12y equals 120? 10. X equals 30? 30. Y equals 30, also 30. All right? So not only is this going to give me some points to plot, but it's also going to give me a sense of my scale. All right? So I know that I need to get from an x-intercept for equation 1, an x-intercept of 20 to a y-intercept of 30, and for equation 2, x-intercept of 10 to a y-intercept of 30. So that just tells me that I need to have a scale sufficient to allow the number 30 to be part of it. So I think there's 20 boxes. We can go by 2s. So this would be 10, 20, bless you, 30, 20, right, so for my first equation, again, I'll do a little highlighter here. Undo that, move it a smidge for some reason. All right, try that again, shall we? All right, so 20 and 10, and then 30 and 30. go. Hit the wrong thing. Let's do another. 20 and 10, 30 and 3. Yeah? All right, yeah, so now again, we're not looking for an intersection. We're looking for a solution, but that solution is going to involve shading. All right? So what I need to do, because we don't have it in y equals mx plus b form. So this is where, like we did the x and y intercept approach, and you'd say, well, is the arrow going to coincide with the shading? And so that's a big question. All right? Something that you could do that'll actually kind of streamline the process pretty significantly would be to create what we call a test point. Right? This allows you to avoid having to go the route of getting each one in the form of y equals mx plus b just to see where the shading would be. All right? Because sometimes just, like if there's a negative that you have to divide by, that could be all it takes to reverse the direction of a sign. All right? So what we do is we choose a convenient test point. So choose a convenient test point. That's not on either line. Speaking of lines, my second one should have been dashed, right? Is there a way I can do that? I don't think I could just erase parts of it. I don't want to freehand that, but I feel like I have to. Border. Nah, I think I just have to freehand it. Gonna look hideous. Yeah, that's the best I can do. All right, so choose convenient test point. That's not on either line. So anything you want. Now, what would be, looking at this entire grid here, what would be the most convenient coordinate? There's a correct answer. There is an ordered pair, x comma y, that is the most convenient or the easiest to work with out of all possibilities. What's the easiest number in existence to work with?
0.
0. So 0, 0. All right. So 0, 0 is what we want to choose if we can. Sometimes 0, 0 will fall on one of the lines, in which case you have to go with something else. If 0, 0 is not a possibility, choose a different coordinate that has 0 in it. So something like 1, 0 or 0, 1. But try to get 0 in there because the math is going to be easier. All right. So we pop it into both of the two equations. So 6 times 0 plus 12 times 0 greater than or equal to 120. And we're just testing for truth. Can close the parentheses. All right. All right, so I'm plugging in my zeros. And we're just asking ourselves, is it true or false in both cases? All right, and we'll get to that in a second, but the truth value will determine the shading. All right, so if it's a true sentence, we shade in the direction of that coordinate. If it's a false sentence, we shade in the opposite direction of that coordinate. All right, so 0, 0 is right down here. So for the first equation, if first inequality, if 0, 0 gives me a true sentence, then I would shade below because that would be in the direction of 0, 0. All right, if it gives me false, I would shade in the opposite direction. All right, so is this a true sentence?
No.
No, because left-hand side gives me 0, which is not greater than or equal to 120. All right, so that would be blue, and that would be false. So I'm going to want to shade away from the 0, 0. For the second one, true. All right, so I always do it with hand gestures. I've mentioned this last time, as a class and then individually. I don't like doing the shading line or equation by equation because it gets too messy. What I do is I say, okay, so I got my first equation here. My first equation here. It's not in the direction of 0, so it's got to be upward. All right. For the other one, it's in the direction of 0, so it has to be downward. So if I'm shading to account for those two relationships, above the blue, below the puke yellow, it's going to be the area in between. All right. So we're looking at this being our solution region. So if you're an employee in this situation, this is your sweet spot. All right. This is where you're going to make the most money while working the least. And then in this interval, you'll have an optimal value that is the perfect number of hours to work where you would actually make the most, but that's a different concept. All right. But this tells us, like if you're working, I'll just pick an ordered pair. If I'm doing 10 hours at the bagel shop and only 5 hours of mowing the lawn, right? I'm not going to make the amount of money that I need to make, and I'll satisfy the idea of not working a lot, but I'm not going to make any money. Right? I'm not going to make a fair or reasonable amount of money. So if I'm living on a budget, I'm not going to satisfy the needs of my budget. All right. So a lot of good stuff going on with this question, and a lot of things to be mindful of. And you could see, even with my table approach, if I'm not careful about how I organize the information, you could run into a problem very quickly. So this is the kind of thing that you definitely want to take your time with. All right. So slow and steady. But it all starts with defining your variables appropriately. Now, if you want, I suppose you could solve each of these equations for y in terms of x, but it just gets ugly very quickly with these word problems. All right, so I don't necessarily recommend you do this or do it that way.